afternoon. Welcome to MCS Geometry Lesson 79 from Saxon Textbook, page 518. We will be covering angles exterior to circles. Please pause now and make sure you have the warm-up done, and then turn it back on and we will continue. The warm-up number 1 is a blank is a line that intersects a circle at 2 points. And that would be a secant, is a line. Number 2 is what is C of a circle? What is the circumference of a circle with a 7-inch diameter in terms of pi? Well, circumference equals 2 pi r or pi d, and so 7 inches times pi is 7 pi inches. And number 3, which length is closest to the minor arc? The length picture is shown here. Which is closest? Here we have a 12-inch radius and a 137-degree arc. And so we want to find which one is closest in length. And I did that the length is 2 pi r times the measure of the angle divided by 360. And I put in the numbers. And I am going to make sure that you plug in those numbers in your calculator to get the answer. Continuing on, there's a new term. An exterior of a circle is the set of all points outside the circle. It does not have to be on a line. An exterior angle has its vertex outside of a circle. As in the example drawn here, the vertex A is outside the circle, and we will just read our new theorem. The measure of an angle, in this case angle 1, whose vertex is outside of a circle, is equal to half of the difference of the intercepted arcs. So this angle equals the measure of this angle minus, the measure of this arc minus the measure of this arc. 1/2 of that difference. And it looks like a equation. Measure of angle 1 equals 1/2 the measure of arc CE minus the measure of arc BD. And here I just notated that it's 1/2 times the big one minus the small one. Please make sure that you put your new theorem on your smart sheet. Now let's look at applying Theorem 79-1. In one of the first we can have 2 secants which intersect outside, or we can have 2 tangents which intersect outside the circle, and third we can have 1 tangent and 1 secant. Example 1 in the book is a proof of Theorem 79.1 with 1 tangent and 1 secant. The method is using the exterior angle theorem with the complement of a straight line, and the interior angle theorem, which is the measure of an angle, equals 1/2 the measure of its arc. And I rewrote that in words. Angle, the measure of the angle, equals 1/2 the measure of the intercepted arc. So the second problem is 2 secants. So first, number 1 up here, we have 2 secants, so we're going to cover 2 secants of a circle, and this is example 2A in your book. Here is what is given. This intercepted arc is 49, this intercepted arc is 13, and they want us to find the measure of angle E. So I wrote the problem down using these notations. And then we plugged in the 49 minus the 13 times 1/2. Get the measure of angle E equals 18. So that is covering that we have both 2 secants. The second example 2B asks us to find measure of an angle, exterior angle, that is 2 tangents. Drawn here is 2 tangents. We are to find the measure of angle Q. We are given only one angle, 110 degrees, measure of the arc. What else do we know? Well, two tangents break up the entire circle into only two parts. This part, the major arc, minor arc, and the major arc. Well, so that means that the measure of arc PR plus the measure of arc, we put in an S so we could make it different, PSR, equals 360. When we solve for this outer greater arc, we get it equal to 250 degrees. So now we just plug it into our theorem 79-1. The measure of angle Q equals 1/2, parentheses, 250 degrees, what we got for our outer arc, minus 110 degrees, the given arc. And that yielded 70 degrees for our answer. Thirdly, we're going to do a problem that uses one tangent and one secant. One tangent line, one secant line. We are to find the measure of angle T. Way out here. We have two angle measures given us. We are given SU and we are given UV. But we are not given SV. But we can still use the whole circle to help us. So we know that SU, measure of arc SU, plus the measure of arc UV, plus the measure of arc VS equals 360 degrees. So let's plug in the ones that we know. 68 plus 154 plus the measure of VS equals 360. And we solve for the measure of arc VS equal to 138. Now we have all that we need for theorem 79-1. The measure of angle T equals 1/2 measure of arc SV minus the arc S, measure of arc, and that gives us a measure of angle T equal to 35 degrees. This is great. You can see that we're just using knowledge that we already have of a circle, 360 degrees. Well, your third example on page 519 is about a lunar eclipse. Well, the night before Easter of this last week, I watched the lunar eclipse. It was on April 4th. So you can go ahead and follow in the example 3 on page 19 in the book, and then I need you to look up pictures on the internet of the eclipse so that you can really follow along. Now, when you turn the page for the lessons practice on A, you will be proving theorem 79-1 in the case of two tangents. Please begin, as you look at that example, by drawing segment EG in. Then follow example 1 as it proved theorem 79-1 with the secant and the tangent, and you should be on your way. Have a lot of fun doing this. Make sure that you write down anything that you needed clarification on your smart sheet, and have a great day.